and Dana are making cookies for the pantry. They only have up to 6 hours to bake. Okay, keywords here are up to 6. They can bake 32 chocolate chip cookies in an hour and 20 snickerdoodle cookies in an hour. They need to make at least 150. All right, so we're looking for things like up to, at least, no more than. Okay, those types of words, those are going to be our numbers at the end of the equation. All right, so we've got 2 types of cookies. We've got chocolate chip, which are our X's, and snickerdoodles, which are our Y's. Okay, so all of our equations are going to be X and Y. All right, so we have up to 6 hours to bake. Okay, does that mean it's going to be greater than or less than 6? Less than, right? Or equal. Okay, so we know we have an equation that's going to end in less than or equal to 6. All right, we've got 2 types of cookies. Okay, each one of those I can make so many in an hour, right? All right, so at least 150. All right, greater than or less than? What do you think? Greater than. I can make at least 150, so I need more than 150, right? All right, so now this equation is where the other numbers are going to come into play, the 32 and the 20. Okay, so X is how many hours it's going to take to make my chocolate chip. Okay, I can make 32 in an hour. Okay, Y is the hours I spend making snickerdoodles, and I can get 20 of those in an hour.
Because it's because you have to roll those. I get the harder recipe.
Yeah, if you roll them in cinnamon and sugar, it takes time.
Oh my gosh. Sounds so good. Sorry.
Okay, so this would be the inequalities that we're writing for this. Okay, we could graph these, and we will eventually, but we're not going to today. We're just going to figure out writing equations. All right, this okay?
Yeah.
All right, let's try another one.
Oh wait, I have a question.
Yeah.
So do we just have to like set up the problem, not solve it?
For today.
Okay.
All right, so the next step, where we're going with this, okay, is we will graph them. We'll figure out where the intersections are, and then we'll figure out how to maximize or minimize our equations. Okay, so if we wanted to know which one would give us the most amount of cookies we could bake, or what the least amount of time we could bake to make that 150. Okay, so that's where we're going with this, to try to figure out to maximize our output or minimize certain criteria, which we probably won't get to till Thursday or Friday. All right, next one. Okay, Kate is selling bracelets and earrings on Etsy to make money for summer vacation. The bracelets, which are X, cost $2, and earrings cost $3. She needs to make at least $100, but can only make up to 40 pieces of jewelry. All right, so our key words here, at least 100 and up to 40. All right, can somebody come up with one equation?
Yeah, the one in case.
Oh, I feel like this, like, it can be less. Oh, greater than or equal to.
Okay, so we've got greater than or equal to 100, because we need at least that much, hopefully more, right? All right, which other things deal with money? So the 100 is dealing with money, right? And we also have the $2 and the $3. Okay, so chances are the $2 and the $3 are going to go with this equation because we're dealing with money. Alright, so that deals with the 2 and the 3 and the 100. Okay, so what would our equation be with the 40? Okay, what does the up to 40 mean? Are we looking at greater than or less than? Less than, right? Alright, are we multiplying our x and our y by anything for this one? This one's just going to be x plus y. Alright, what's the difference between a system of equations and a system of inequalities?
That's a good question. We don't know the answer to that. I wish I knew the answer.
Alright, so we were doing system of inequalities last week before we left, right? Okay, remember we were shading an area where they overlapped? Okay? So a system of inequalities is going to give us a lot of different data points, right? What were we doing when we graphed systems of equations? What were we looking for? What were we looking for when we were solving systems of equations? That was your substitution, elimination, the graphing. What did our answer look like?
Big. Difference is that we had to solve for both. This one we don't solve for. I don't know.
We had to solve for both what?
X and Y.
X and Y, right? So systems of equations gave us an X value and a Y value, right?
Mm-hmm. This one we just had to find one, don't we? I don't know, actually. I have no idea. The brain was too long. I don't think when she saw it, so I don't put them right around.
No, usually when she does
Alright, systems of equations, right? When we graphed them, we were looking for that, right? The intersection. Okay, systems of inequalities, when we graphed them, we had that shaded area that met criteria for both, right? Okay, what's the difference?
One's a circle and I'm sorry, I really
What did we call this? An intersection.
like fast pass.
Alright, for inequalities, do we have just one answer?
No.
No. Okay, this is
No, I didn't.
okay, chances are that question will be on your next test.
Yeah. Except last year, sure.
Okay, systems of equations, we're looking for a singular intersection point. A system of inequalities are all the points that meet the criteria.
So
I just hate putting anything that I don't know because you'll never go back. My skin's so sensitive. That's why I said for research I only use the face. I'm 13 and
Alright, next one. Okay, Cole is doing a basketball challenge for charity. In order to win money for the charity, he needs to score at least 20 points in less than 10 shots. Alright, X is the number of 2-point shots and Y is the number of 3-point shots. Alright, so what are the key words in here? Okay, at least 20 and less than 10. Okay, so those are going to be the numbers at the end of the two equations. And then we have 2 and 3. Alright, that tells us the points that each is worth. Guys, Jake, this is not working for you over there. Okay. Alright, so the 2 and the 3 tell us how many points we're going to get. Okay, so which equation is that going to go with? The 20 or the 10? What? The 20, right? 20 is how many points? This tells you our point value. Okay, so if we have 2x plus 3y, are we greater than 20 or less than 20? Greater than. Right? We need at least 20, which means greater than or equal. Alright, which leaves our x plus y. Alright, is less than 10 shots. Alright, so words like at least means greater than or equal. Okay, the other one we had was up to. Okay, which means less than or equal. Okay, another one you'll see is at most. What does that mean? Less? Yeah.
That's the most.
Okay.